Bismillahirrahmanirrahim. Assalamu alaikum student and welcome in college physics. So student आज हम डिस्कस करेंगे spinning top with step by step notes and precessional velocity and precessional motion of the spinning top. Spinning tops क्या होता है? A conical tie that can be set to spin with a quick twist is called spinning top. The spinning tops illustrate several physical concepts including angular velocity, angular momentum, torque, etc. And usually spinning tops used for amuse the children. These are some colorful shapes of the spinning top, correct? And by the help of this spinning top, we understand several physical concepts like what is angular velocity, angular momentum, torque, and so on. Spinning top usually used students or kids in houses for its amusement. In present lecture, we discuss the following points, that is, what is precessional velocity of spinning top and how will we obtain its mathematical form, this one. Why spinning top not fall to ground, and why precessional velocity of spinning top increases before just fall. Precessional velocity and precessional motion क्या होता है? The rotational motion of a self-rotating spinning top axis about a central fixed z-axis is called precessional motion, and its corresponding velocity is called precessional velocity. And this can be understood by using the following video clip. अगर इस वीडियो क्लिप को आप देखें तो आपको प्रेसेशनल मोशन और प्रेसेशनल वेलोसिटी की कंसेप्ट क्लियर हो जाएगी. Now, before the understanding of angular velocity omega and precessional motion and precessional angular velocity omega p, let's watch this video. ये हमारे पास एक स्पिनिंग टॉप है और इस स्पिनिंग टॉप जो है इसके टू एक्सिस ऑफ रोटेशन है. एक एक्सिस ऑफ रोटेशन इसका ये है, दिस वन, एंड विद स्पिनिंग टॉप रोटेट अबाउट इट्स ओन एक्सिस, दिस वन, एंड द एंगुलर वेलोसिटी अबाउट दिस एक्सिस इज नोन एज ओमेगा. सिमिलरली द अदर एक्सिस ऑफ रोटेशन इज दिस वन. दिस स्पिनिंग टॉप rotate about this axis which is known as z axis, like this one. Now the angular velocity of this spinning top in this path is known as precessional angular velocity, and precessional angular velocity the spinning top constructed a cone like this one. So to understand omega and omega p, let's watch the video again. This one, it having two types angular velocity, one is its own axis and other is about this central axis. This motion about the central axis is known as precessional velocity. For precessional velocity, the axis of rotation is this one, while for angular velocity, the axis of rotation is this one. Means the angular velocity is that one in which the spinning top rotates about its own axis, while the precessional velocity is that velocity in which the spinning top rotates around this axis in which it constructed a cone. Now, derivation of precessional velocity. Let's consider a spinning top initially rotates about a certain vertical z-axis as shown in the figure. ये हमारे पास एक spinning top है और इस z एक्सिस के अराउंड जो है ये रोटेट करता है. Then due to air friction it incline and its center of mass disturbed from central axis point O to some other point A as shown in the figure. In this case the velocity omega make angle theta to the central axis and start rotation due to an external torque, that is due to the weight of the top, that is mg, and position vector r as shown in the figure. For the case of simplicity, we replace top by a particle of mass capital M located at the top center of mass as shown in the figure. अगर इस फिगर को देखें हमारे पास ये एक स्पिन टॉप है, ई इसका सेंटर ऑफ मास है, इनिशियली ये इस जी एक्सिस के अराउंड जो है मूव करता है और ये फॉल क्यों नहीं होता, क्योंकि इसकी रोटेशनल एंगुलर वेलोसिटी और एंगुलर मोमेंटम जो है रोटेशनल एंगुलर मोमेंटम उसकी डायरेक्शन अपवर्ड है, मींस इसकी काइनेटिक रोटेशनल काइनेटिक एनर्जी है और इस तीनों फैक्टर की वजह से ये जो है इस पोजीशन के अराउंड जो है रोटेट करता है और फॉल नहीं होता। अगर इसकी रोटेशनल वेलोसिटी को हम जीरो कर दें तो ये ऑटोमेटिकली जो है गिर जाएगा। नाउ इनिशियली दिस रोटेट अराउंड दिस जी एक्सिस like this figure, but due to air friction its center of mass will be disturbed, means its center of mass is deviate from this point to this point and now start motion like this one. So it having two type velocity, one is rotational angular velocity, this one is secondly it rotate in this path. The rotational motion of the spinning top in this path is known as precessional motion and its velocity is known as precessional velocity, and the circle traced by this spinning top is known as precision circle. Now आसानी के खातिर हम इस तरह करते हैं कि इस स्पिनिंग टॉप को हटाते हैं और सिर्फ इस सेंटर ऑफ मास को ट्रीट करते हैं, इसके मोशन को देखते हैं। करेक्ट, मीन्स द स्पिनिंग टॉप नाउ रिप्लेस बाय ए सेंटर ऑफ मास फॉर द केस ऑफ simplicity. So initially let's suppose the spinning top is here, so the weight of the spinning top is downward mg and the center of mass of the spinning top is r distance away from this point O. Correct? Now अगर इसको हम देखें हमारे पास ये m है मिसाल के तौर पर, हमारे पास a है मिसाल के तौर पर, हमारे पास O है and this is our position vector r. So this will be our perpendicular, means this will be our sin theta, this will be our cos theta and this is our r. Now the weight of the spinning top is downward, that is mg, and the moment arm is this one r sin theta. So we know that there will be a physical quantity perpendicular to the moment arm and weight of the object, force of the object, weight of the object, and that quantity is known as torque. So it means when the spinning top rotate in this circle, precision circle, then there will be a torque act on the spinning top, that is tau, and the direction of torque will be perpendicular to weight of the spinning top and radius vector component r sin theta. So the torque produced on this spinning top is what? That is tau equal to r f sin theta, but here f is the weight of the spinning top, means f equal to mg, so torque act on the spinning top, tau equal to mg r sin theta, and this tau rotate the spinning top around this z axis in the form of precessional velocity omega p. Now the torque which is perpendicular to the axis of the top and therefore perpendicular to the L angular momentum, it change the direction of L but not its magnitude. The change in angular momentum in a small increment of time dt is given by this one, as torque is what? The time rate of change of angular momentum, or this expression can be written as r in magnitude from del L equal to tau into dt. Now the effect of torque on spinning top is it doesn't change magnitude of angular momentum L but only change its direction, and this torque is cause of precessional motion and precessional velocity. इस फिगर को देखिए हमारे पास जो है this is center of mass r spinning top and the direction of angular momentum is always perpendicular to this spinning top, means the direction of angular momentum will be in this direction. So this is angular momentum and this will be L sin theta, perpendicular component of L, that is L sin theta, and tau is this one. Now if this spinning top move from this point to this point, so change in angular momentum will be dl, and this is known as L sin theta, and this is a line is also known as L sin theta. L sin theta is the radius of precision circle and this make angle d pi. So when a spinning top move from this point to this point, its change in angular momentum is del L, and this side is known as radius of precession circle, that is L sine theta, and this is L sine theta, and this angle is known as d pi. Yeah, we know that from elementary vectors is equal to r sin theta. So अगर इस ट्राइंगल को हम यहाँ पर रखें, ये हमारे पास L sin थीटा, ये L sin थीटा, ये DL और ये d pi. So we obtain d pi या angular displacement equal to dl divided by L sin theta by using this relation is equal to r theta. अगर इस रिलेशन को हम यूज करें इस ट्राइंगल के लिए, this triangle के लिए, so we obtain the change in angular displacement d pi equal to dl divided by L sin theta, where this is known as dl, this r is known as L sin theta, and this theta is known as d pi. So angular displacement d pi equal to dl divided by L sin theta. Now the precessional angular speed or precessional angular velocity omega p simply defined as omega p is equal to the time rate of change of angular displacement. So omega p as it is, and d pi by dt, and we know that d pi from this equation number 3, d pi is what? D pi is dl divided by L sin theta. And for equation number 2, dl is what? dl is equal to ta into dt. So by simplify this, we obtain the precessional angular velocity omega p, or precessional velocity omega p equal to mgr divided by L, where m is mass of the spinning top, g is gravitational acceleration, r is the distance of spinning top from the point O, and omega p equal to mgr, and angular momentum is the product of rotational inertia and angular velocity. So omega p is equal to mgr divided by I omega. Now consequences of precessional velocity omega p, that is mgr by L, equal to mgr divided by I rotational inertia multiplied by angular velocity omega. So consequences number first, the precessional speed is inversely proportional to the angular momentum L, and thus to the rotational angular speed. The faster the top is spinning, the slower it will precess. Conversely, as pressure slow down the rotational angular speed, the precessional angular speed increases. याद है कि हमारे पास कोई स्पिनिंग टॉप हो, तो इनिशियली इस वर्टिकल लाइन में रोटेट करता हो, तो इसकी जो वेलोसिटी होती है ओमेगा, वो हमारे पास वेरी वेरी लार्ज होती है. सो इन ओमेगा इज वेरी वेरी लार्ज, देन इट्स precessional speed will be 0. But as well as this spinning top deviate from its central axis and start motion in a conical form, so it means its angular velocity omega will be decreased. When angular omega velocity is decreased, then precessional velocity omega p will be increased. Means अगर हमारे पास कोई भी स्पिनिंग टॉप हो और वो जो है इनिशियली इस तरह से मूव करता हो, मीन्स वर्टिकल लाइन में, तो इसकी ओमेगा पी हमारे पास क्या होगी? प्रेसेशनल स्पीड हमारे पास 0 होगी. बट व्हेन इट डिविएट फ्रॉम इट्स this point and start motion in a conical form, then the velocity, the angular velocity of this spinning top will be decreased when start motion in a form of a conical path. So when this omega decrease, then its precessional speed will be increased. And point 2, the precessional velocity will be 0 of gravitational acceleration g0. means अगर हमारे पास कोई भी spinning top हो और ऐसी रीजन में मूव करता हो जिस रीजन में ग्रेविटेशनल एक्सेलरेशन 0 हो, तो फिर हमारे पास उस स्पिनिंग टॉप की जो प्रेसेशनल वेलोसिटी होगी वो क्या होगी? वो भी हमारे पास 0 होगी. एंड कंसीक्वेंसेस नंबर 3, प्रेसेशनल वेलोसिटी इज ग्रेटर एट पोल देन इक्वेटर बिकॉज ग्रेविटेशनल एक्सेलरेशन g एट पोल इज ग्रेटर देन इक्वेटर. एंड पॉइंट नंबर 4, द रिलेशन बिटवीन प्रेसेशनल वेलोसिटी, टॉर्क एंड एंगुलर मोमेंटम टाई इक्वल टू ओमेगा p क्रॉस l means the torque act on the spinning top always perpendicular to the precessional velocity and angular momentum of the spinning top. And point number 5, द प्रेसिशनल वेलोसिटी इंडिपेंडेंट थीटा दैट इज एंगल ऑफ इंक्लिनेशन मीन्स हमारे पास ये कोई स्पिन एंड टॉप हो और इस पाथ में मूव करता हो, एक कॉनिकल पाथ में मूव करता हो, उसकी प्रेसिशनल वेलोसिटी हो, लेकिन इसका जो सेंटर ऑफ मास है वो इस एक्सिस के साथ 30 एंगल बनाता है, करेक्ट। और फिर मिसाल के तौर पर हमारे पास एक स्पिन एंड टॉप है और उस कॉनिकल पाथ में मूव करता है, लेकिन इसका जो सेंटर ऑफ मास है वो यहाँ पर 20 एंगल बनाता है। अगर इन दोनों का एंगुलर मोमेंटम मास और आर कांस्टेंट हो तो याद रखिए इसकी प्रेसिशनल स्पीड पर कोई भी इफेक्ट नहीं पड़ेगी, चाहे वो स्पिन एंड टॉप एक लार्ज रेडियस सर्कल में मूव करे या स्मॉल रेडियस सर्कल में मूव करे। मींस अगर हमारे पास इस कॉनिकल पाथ की रेडियस ज़्यादा हो या कम हो, लेकिन उसकी एम जी आर और एल कांस्टेंट हो तो ओमेगा पी हमारे पास कांस्टेंट होगा। ये आर जो है याद रखिए ये रेडियस ऑफ दिस सर्कल नहीं है, ये आर जो है द डिस्टेंस ऑफ दिस सेंटर मास फ्रॉम दिस फिक्स पॉइंट है।